If I had 900 what?
At the top part. I mean,
Up here?
Yeah.
If I had 900 over 1,000, I couldn't get any holes out of it.
So it'd be 100.
I mean, the only thing I could do here would be to reduce it. It takes 1,000 to make a hole. I don't have a hole. I just still have a big piece. But I can reduce this, and I can say 100 goes into both of them. 100 goes into 900 9 times, and 100 goes into 1,000 10 times. And that's all I could do is reduce it to 9/10. So I'm saying having 900 pieces out of something that it takes 1,000 to make a hole is the same as having 9 pieces out of something that it takes 10 to make a hole. I still don't have a hole yet, I just have a piece.
Okay.
But sometimes we just have a piece. You don't always have $1.
Right.
You have 90 cents, 9 dimes.
But that's how you work out that one. Instead of putting 100 up under there, you can put 1,000 up under there. I'm not understanding.
I'm not understanding your question. You said if I had 900 what? I don't understand 900. Huh?
I don't know. Never mind. Okay, because I can't even put it in words.
It just depends on what the problem is as to what you put under here.
What kind of problem is more likely to show up? The regular common, like decimal?
Both of them,
notation,
any of them, you
or
no
the
more
one at the
likely.
bottom?
That's why you have to know how to work any kind of problem. A decimal, that's what you have to understand. A decimal and a fraction is just as valid as a whole number. Any problem, how can I tell you? If I tell you to go measure that wall,
And it all goes back to the whole anyway, right?
Yeah.
That's what
So
I
you just gotta know the
started
steps real well, so that.
you gotta know all the steps, yeah, because you don't know what's gonna happen. I tell you to add that wall, I want you to see how much paint maybe I wanna put on that wall. You may have to figure that out yourself. You gotta measure that wall, you gotta measure that wall. How can I tell you that wall is gonna end on a whole number? That wall might end on 1/8.
So you're showing us.
That
how-
wall might end on 2/10.
Showing us how the decimals relate to the fractions.
Why do you
Right,
work that?
I'm showing you that they're the same.
Well, how do you
Decimals
work
and
that?
fractions are the same.
How do you work that what you just said that they might?
You have to be able to follow the steps of adding fractions.
Okay.
You have to be able to know that you have to line it up vertically, and actually that's what we did last week was fractions. You add them up vertically, you find a common denominator,
Or you
and
make
then
it
you have to add the numerator.
you're making a improper fraction.
When you multiply, she was asking about adding. Okay, you're asking two different questions. There are different steps for adding them than there are for multiplying. That's why you got to memorize those steps. When you multiply fractions, it says change all whole numbers and all mixed numbers into improper fractions. So I had to change this mixed number into this in order to multiply, because that's what the rule says. See, I couldn't leave it 3 and 3, 35 over 100. Where if I was adding these two together, it would still stay there. I just have to find a common denominator. If I was adding 3 and 35 hundredths and adding it to 7/10, that's a different rule. I can't add a hundredth with a tenth. I have to change them both to the same thing. I have to find what they can both be cut into. I can cut them both into hundredths because I can multiply that and make these into hundredths as well. Find the common denominator, which was 100. Add the numerators, which gave me 105 of these hundredths in 3 wholes. Simplify or reduce your answer. That's the fourth thing. If it only took 100 pieces to make a whole and I had 105 pieces, I can make another whole. Instead of having 3 holes, now I got 4. And I'd have 5 of those pieces left. Then I could reduce that because there is a number that goes into 5 and into 100. If you pull out that thing one more time, I'm going to send you out there because if all you're going to do is text, you're not going to learn nothing anyway. Okay? So we're going to reduce this. 5 goes into 5. 5 goes into 100. Okay? If it were adding fractions. But when you multiply fractions, the rules don't say find the common denominator. It says write the problem horizontally, change all whole numbers and mixed numbers into improper fractions, then multiply top times top, bottom times bottom, simplify, and then I'd have to reduce this. Because I know 5 goes into both of them because they end in a 5 or 0. I'd have to keep going down, down, down until nothing goes into both of them evenly. Decimals don't have to be reduced. But this still says 2 and 345 thousandths. But when you multiply with decimals, the point was you don't have to go through all of this. Just multiply as if they're whole numbers, but understand that they're not. Once you get your answer, you count how many decimal places you have in your problem, put the same number of decimal places in your answer, and you have the correct answer. Sometimes, oh, let's see if it was like this, okay. Let's say if that was your problem. Now, I multiplied by the 3. I'm not going to go and multiply by the 0 because it's just going to be 0 all through here. It's just going to leave this, right? But now I have 1, 2, 3, 4, 5 places past the decimal. And I only had 4 numbers. I'd have to add a 0 here and then put my decimal. Because this is 300ths times thousandths is going to be 100 thousandths, right? When I multiply 100 times 1,000, I'm going to get 100 thousandths as my denominator. It's got to be 100 thousandths here. Tenths, hundredths, thousandths, 10 thousandths, 100 thousandths. It's got to be 100 thousandths here because you're not multiplying 2,005 times 3. You're multiplying 2 and 5 thousandths times 3 hundredths. And when you multiply hundredths times thousandths, your answer has to be in 100 thousandths. And this is 6,015 hundred thousandths. Because these are tenths, hundredths, thousandths, 10 thousandths, 100 thousandths. So it's easier though just to count. 1, 2, 3, 4, 5. I had to have 1, 2, 3, 4. I knew I needed 5. Add the 0, then you had 5. It could have been 0.003. Your answer still just going to be the 6015 because 0 times everything's going to be 0 and 0. See? But now I have 1, 2, 3, 4, 5, 6 places. I'd have to have 1, 2, 3, 4, 5, 6 places. And then that. Because it's got to be, this is thousandths times thousandths, that's going to be millions. I have to have millions in my answer. Because this is 2 and 5 thousandths times 3 thousandths. You're going to be multiplying thousandths times thousandths. You see? You have to understand these are still fractions. 5 thousandths. Not 5. This is not 2005. This is not 5 wholes. These aren't even 5 pennies. It takes 10 of these to even make a penny. And I only have 5. You see what I'm saying? So your answer is not going to be as if this is 5 whole dollars you're multiplying by. And that's how you do. You count how many places you have. Put the same number of places in your answer, and that's all you have to worry about when you multiply decimals. Okay? So when you add or subtract them, what are you going to do? Anybody? When you add or subtract decimals, what do you have to do? What is the key? Keep the decimal point lined up. When you multiply decimals, what's the thing you have to remember to do?
How many decimal spaces?
Count the decimal places in your problem, and that's how many decimal places you have to have in your answer. Because look, while you guys are trying to think about what you need to memorize, those are the things you have to memorize. Every problem has a key to working it. Something you have to remember about it. Something that you've been taught about it. When you see adding fractions, you have to remember, I got to get a common denominator. You see what I'm saying? When you see a problem and it's subtracting fractions, you have to remember, I have to get a common denominator. When you multiply fractions, you have to remember, I have to change those mixed numbers and whole numbers into improper fractions first. When you divide fractions, you have to remember, oh, I'm gonna have to do all the same thing I did with multiplying, but then I have to write the first one, change the multiplication, flip the second one. Then I just multiply it. Those are the things you have to memorize, because those are gonna be the steps every time you do a problem like that. When you add decimals, the only thing you have to remember that you weren't born knowing is that you keep the decimal points lined up. So that's what you have to make yourself remember. Anytime I see a problem, and it's a decimal problem, and I'm adding or subtracting it, I have to line up my decimals. To help myself out, I can add those zeros so that it's easy for me to see where my lines are. When I multiply decimals, only thing you have to remember that's different is that, because you already know how to multiply whole numbers, right? So it's not like you have to learn that. So all you have to remember, what's different? What's different when you multiply decimals is that once I multiply those numbers as if they're whole numbers, I gotta remember to count the places and see how many decimal places I have in my problem so that I can put the same number of decimal places in the answer. That's all you gotta remember. If you always remember that, and if you do the multiplication right, your problem's gonna be right. Because that's the only thing different. When you divide by decimals, there are two things you have to remember. First of all, sometimes there is no decimal point out there. But there is one in here. Sometimes there is a decimal